So in this video, I wanted to talk to you a little bit about slope as rate of change, and we will talk a little bit about a horizontal and vertical lines at the end. So to start with, I have included a table here, and you can clearly see 4 x's and 4 y values, and I made myself a little graph. It's not very professional, but we'll deal with this. So I'm going to start plotting in some of these points. So the first order pair, according to my table, is 1, 8. So in order for me to locate this point, I will go 1 right and 8 up. So it would be right here. The second order pair would be 4, 6, be here. So this is the 1, 8, and this is the 4, 6. The third order pair would be 7, and it would be 4 up, so it would be right here. 7, 4. And I can go ahead and plot to get a sense of how this line looks like. So in order for us to calculate the slope, we have 2 methods. One is what we call slope triangle. So let's start with that first. Just going to choose a different color here to show you. So for the slope triangle, I can go from one point to the other. So let's say I'm going from here to here. So you can clearly see it's called slope triangle because I'm making a triangle. And if I want to go from here to here, I'm going to go from the value of 8 to the value of 6. So I'm going to go down 2 units. Down 2 units, which means -2. I'm here, and I'm going to go from here to here. I'm going to go to the right from 1 to 4. That means 3 units to the right. So slope is y over x, so that tells me that my slope would be -2 over 3. Now, let's say you didn't want to go from here to here. You wanted to go from here to the other point. All right, let's go and grab another marker. So I'm going to go from here to all the way down here now. There's another slope triangle. So on the y movement, I'm going from 8 down to 4, down. So I'm talking about a difference 8 to 4, down 4, so -4. And I'm here, and I'm going to go from 1 all the way to 7. 1 to 7, I'm going right, so it's 6 units. So this is my slope, and you can clearly see that I can reduce that by 2, and guess what? I'm getting -2/3 again. So this is the slope of this line by using the slope triangle. Now, let's go now and calculate the slope by using the slope formula. If you remember from the past, slope formula is formula y2 minus y1 over x2 minus x1. So the formula never changes. The order pairs can be different. So we have a bunch of order pairs here. We only need 2. So let's go ahead and grab, why not, the first and the last maybe for now. Now, I suggest to my students, or I tell them, that it's nice if they label which is which. So for example, this is your x1, this is your y1, this is your x2, and this is your y2. So label them so you know which is which, so you don't make a mistake when you substitute. So I'm ready to substitute. So according to the formula, y2 is 2, minus, according to the formula, y1 for me is 8. On the bottom, x2 is 10, minus x1 is 1. So if I clean the top, 2 minus 8 is -6, and 10 minus 1 is 9. And if you simplify top and bottom by 3, if you reduce them, guess what? You will get again -2/3, which is what I'm expected to get according to the slope triangle before. Because I'm talking about the same points, the same line, therefore it should be the same answer. So let's say you want to use 2 other pairs from the same table. I'm going to use the middle 2 points, 4, 6, and 7,4. So let me go right here. Now common sense is telling you that we should be getting the same answer again. So let's see. I'm going to go ahead and label them again from the bottom here, x1, y1, x2, y2. So I'm starting my substitution. y2 is 4, minus from the formula, y1 is 6. x2 is 7, minus from the formula, x1 is 4. 4 minus 6 is -2, and 7 minus 4 is 3. So there you have it again, -2/3 negative 2 over 3, negative 2 over 3, negative 2 over 3. So no matter how you calculate the formula or what method you choose, if you do it correctly, you should be getting the same answer, negative 2/3. Now, I want to talk to you a bit about slope and its cases when we're talking about lines. So I'm going to put here slope and line connection maybe. So when it comes to slope, we have 4 different cases. So I'm going to make myself here 4. There we go. So we can have the slope to be positive. If the slope is positive, we expect the line from left to right. We always talk about lines from left to right, to be increasing. So the line would be something like this, increasing. If the slope is negative, which was the case here, we expect the line to be decreasing from left to right. So it's going to be looking something like this. The slope can be 0. If the slope is 0, the line will be a horizontal line. And if the slope is undefined, then we're talking about a line that is vertical. So those connections are important for us to know, and I can go vice versa. For example, if they're telling me that the line is vertical, I should automatically know that my slope is undefined. Think about this. If the line is vertical and you grab yourself 2 points on the line, any 2 points, those 2 points you would have from here to here, you have movement going up or down, but you don't have movement going left or right. So if you're thinking about the slope formula, if you go to the bottom, it would be 0 minus 0. I mean, it would be a value minus itself on the bottom. So you would have 0 on the bottom, undefined. You cannot divide by 0 in math. That's why the slope would be undefined. Now, a little bit more about horizontal or vertical lines. Let's just make this graph. Let's talk here about horizontal lines. All right, so I'm going to go ahead and bring a horizontal line here because I want you to see something about it. Okay, so I'm going to go and grab myself maybe 3 points. 1, 2, and why not right here, 3. All right, so if I want to go ahead and name those points, assuming that I'm going like by units of 1, it looks like this point probably, there we go. This point would be 1 left and 2 up, so this would be negative 1, 2. This point would be nowhere left or right, but up 2, so this would be 0, 2. And this point right here would be 1 right and 2 up, so it would be 1, 2. So if you compare those 2 points, you clearly see something interesting. You see that the y value is 2, 2, 2. So that really defines for us the equation of the horizontal line. So any horizontal line should have equation y equals a specific number. To be specific here, the equation of this line would be y equals 2. So the points are really giving you the answer if you're observant enough. Now, talking about the slope, we said before that the slope, we expect it to be 0. So let's see why that is the case. So I'm going to use my slope formula. And I'm going to go ahead and grab any 2 points. These are fine. So on the top, I will have my y2 minus my y1. And on the bottom, I'm going to have my x2 minus my x1. So here's what I have. I have 0 over 1. Nothing divided into one piece would be nothing. So the slope is indeed 0. Another way to look at this, going from this point to this, I'm going nowhere up or down. So the vertical movement is 0. But I do go to the right some units. So 0 over anything is 0. That's why a horizontal line will have always slope of 0. Let's go and talk a little about a vertical line now. There's my graph. I'm going to grab myself a vertical line. There we go, here. I'm going to go ahead and plot some points. Here's one, here's another, Here's another. And let's assume that I'm going by ones here. All right, so if I want to go and check the order pairs, this first order pair up here, I'm going to go one, assuming that I'm going by 1 unit, 1 left, 1 up. So this would be negative 1, comma 1. This unit, I'm going, this point, I'm going 1 unit left, and I'm staying there. So this would be negative 1, comma 0. And this would be 1 left and 1 down. Again, if you compare those points, here's what you see. You see the x value, negative 1, negative 1, negative 1. So that defines my equation. X equals the specific value that the points are telling me, negative 1. Now, let's see or talk about the slope. We expect it to be undefined, as we said before, but let's see why. So I'm going to go ahead right here and squeeze it in here. Grab any 2 points that you want. I'm going to grab the first and the last. So if I go from here to here, I'm going to have negative 1 minus 1 here, minus this. And I'm going to have on the bottom, be careful, negative 1 minus from the formula, and the x1 is negative 1 also. If I clean that up, on the top I have negative 2 over, and negative times a negative is positive. Negative 1 plus 1 is 0. Negative 2 over 0. I can't divide by 0. So the slope is undefined. A last thing on for this video, just be very careful with equations of horizontal and vertical lines, because students tend to be very confused. For example, we said here that a horizontal line should be y equals a number, but students think, oh, the x-axis is a horizontal line, so it should be x equals a number. It doesn't work like that. It works the opposite way. Same thing with the vertical lines. A student would expect the vertical line to be like the y-axis, y equals. No, it's x equals a number. It's the opposite. So be careful with those concepts.